Good evening, students. My name is Andrew Duminy. Today's project will be done on different holes. So what I've done so far is, apologies for the voice, my voice is a little bit hoarse today. Been struggling with the flu for a couple of days now. So I'm doing my best to try and just complete this. So what we did was, or what I've done so far is to try and explain the different types of holes and how we draw it. So I've set up a template already with 4 different type of holes that I'll be going through with. I've drawn a little block about 150 by 50 millimeters long and 50 millimeters wide as well. And then I've drawn about 4 equally sized holes as well. They are about 20 millimeters in diameter. Let's just note that quickly. Each hole diameter of 20. That's the symbol for the diameter that the hole size will be. Then I extruded the lines going upwards. They're very faint, they're very light lines. They don't need to be dark at all. They will just show that the lines protrude on or are that size. So that would mean that the distance from there to there would be 20 millimeters as well. So the first type of hole, which is a bore hole, a simple hole is what people call it. It's just a hole that you normally use as a drill, and it goes right through the actual plate itself. Got a little bit of example, if you can see here. This is literally a hole that goes straight through the plate. Right, so the way that is shown on the side view is literally just 2 lines, darkened lines, straight through the plate itself. So this over here will be our top view, and this over here apologies, I'm just trying to not break the setup. I will try and show a picture of the setup that I have. So in the last video that I had, the lighting wasn't that good, so I've got literally 2 lights, one LED light on top and one standing light on the side to try and get the best lighting possible. So this will be our side view, like that. So this, just to note, it will be a simple hole. So this is literally just a hole that's drilled through normally, just 2 lines on the side, and to indicate the center line, a light center line going right through. Dark holes, because that's obviously the way we're drilling through the plate itself. The second type of hole that we'll be discussing today would be our tapped hole. So I'll just make a note that this is the tapped hole. So basically a tapped hole, more or less the same as you look by the example that I have here. Tapped itself, then inside the tap itself it's got a thread that's put right around it. The thread is obviously for the bolt to go in and out of it itself. As shown inside, there's a little bit of a thread there. So it's shown exactly the same. Extending the lines upwards, dark side lines, or dark to show the exterior. Then to show the tap, all we do is we show the tapped section. Let's get a smaller ruler. Here we go. Smaller ruler. About 1 millimeter outwards from both sides. 1 millimeter outwards from both sides. And the exterior itself will show that that's the size of the tapping, or the size of the thread, sorry. And that is basically what that is. The fourth hole is what I would call a counter bore hole, and it's basically a hole that goes or doesn't go all the way through. So it's basically the same as a cymbal hole, the same anode as what a cymbal hole would look like, but it doesn't go all the way through. So what I'm going to do is I'm going to measure about 30 millimeters down, 30 millimeters down, and that is how deep the hole will obviously go. Now I'm stopping here because there are different ways you can rotate this. If you look at this bolt itself, or this bolt, it's got a flat head. So in a counter bore hole, you can have a flat head going all the way across, just ended by a straight going down across. But if you're using a normal drill bit for metal itself, you would measure about 45 degrees. Sorry, you would measure about 45 degree. Working with space is not easy. .45 degrees going down. Similarly, 45 degrees going down. Then I would just darken those lines itself. So this would depend on what kind of drill bit or what kind, how you're boring the hole through. This would mean that the hole is basically going down to a depth of about 30 millimeters. 30 millimeters, stopping there, and that would be the tip of your bore hole that you're actually using to go all the way through. Now the last hole that I'll be discussing is a tapped hole. Tapped hole. Apologies, not a tapped hole. I've already done a tapped hole. Apologies for that. The last hole we're doing is a countersink hole. Countersunk hole. I want to erase that, but if I erase this whole thing is going to fall. I'm a bit scared of that at the moment. So what I'll do is, a countersink hole is basically a screw that sits flush on the actual bed that it's been embossed into. So what we do to draw this is a countersunk hole would be on a 45 degree angle. To draw this, we'd use our 45 degree square. Just hopefully it doesn't fall again. So 45 degrees going in. Turn it around. Just use this as gently as possible. 45 degrees going in as well. The distance on this side is always 90 degrees on a countersunk hole. Okay, not always, depending on how or what kind of bore you're actually using or what kind of actual screw you're using to fit. Most of the time is about a 90 degree angle, or 45, giving you that 90 degree angle. So that would be the head of your screw over there, the size over there, and that will be the size of the screw that is actually going in. I actually drew this wrong now. This should actually be the